Bismillahirrahmanirrahim. So in this given problem, the output of a linear system is y of t is equal to 10 e raised power minus t cos 4t u of t, when the input is x of t is equal to e raised power minus t for e raised power minus t u of t. Find the transfer function of the system and its impulse response. So in this problem we are given y of t is equal to 10 e raised power minus t cos 4t u of t, right? U of t here signifies that this function is 0 before time t0, and this function has this value at time t0 and afterwards, and x of t is equal to e raised power minus t u of t, right? So the Laplace transform for y of t, let us represent this with y of s, which is the Laplace transform for y of t. It will be equal to, so this is in the form e raised power minus at cos omega t. So cos omega t has a transfer function of s over s square plus omega square, right? So and e raised power minus t adds plus 1 to the s, because a here is minus 1, right? So the Laplace transform for this will be 10, this 10 here, into s plus 1 divided by s plus 1 square plus omega square, which is 4. So this is 4 squared. So this is the Laplace transform of the output y of t. Similarly, the Laplace transform of the input x of t will be equal to, so this is simply e raised power minus t u of t, so this is simply 1 over s plus 1, right? Now h of s, the transfer function is given by the ratio of y of s to x of s. So we put in the values for y of s and x of s. So y of s was 10 into s plus 1 divided by s plus 1 squared plus 4 squared, and this is divided by x of s, right? So that will be that is 1 over s plus 1. So when we divide it with the x of s, this will be s plus 1 over 1, right? So h of s is equal to 10 into s plus 1 squared, this s plus 1 and multiplied by this s plus 1 divided by, so let us open this square. So this will be s squared plus 2s plus 1 plus 16. So h of s is equal to 10. Let's open this square also. So this is s square plus 2s plus 1 divided by s square plus 2s plus 17. So this is the Laplace transform h of s of the given system for which the output and input are given. So we had to find the Laplace transfer function of the system that we have found, and now we need to find out its impulse response. So for the impulse response is h of t, and that is the inverse Laplace transform of h of s, right? So we need to find the inverse Laplace transform of this transfer function. For this we need to expand this to find out the inverse Laplace transform. So uh, let us express this transfer function like this. This 10 is multiplied and we take it common, so this is s square plus 2s plus, we write it this one as 17 minus 16 minus 17 minus 16 is 1, right? Why would we write this? Because this term here, this denominator here is s square plus 2s plus 17. So the degrees of both the numerator and denominator are the same. So we need to write it in such a way that we can apply the partial fractions, and then we can find out the inverse Laplace transform. So this is s square plus 2s plus 17, right? So this can be written as h of s is equal to 10. So s square plus 2s plus 17 divided by this is 1, right? S square plus 2s plus 17 divided by s square plus 2s plus 17 is 1, and then minus 16 divided by s square plus 2s plus 17, right? So h of s is equal to this 10 here, and this is 1 here, and this is minus, and now this can be written back to this form, right? We expanded this and arrived at this form here, so we can write it back to this form. So minus 16 by completing the square, right? So this is s square plus 2 plus 1, s square plus 1 squared and plus 4 squared, plus 4 squared, right? And we know that the Laplace transform of e raised power minus at sine omega t is given by omega over s plus a square plus omega square, right? So we have omega here is 4, right? So we can simply write it like this: h of s is equal to 10, this is 1, and we can write it 4 multiplied by 4. So 4 multiplied by 4 here, so this is s plus 1 squared plus 4 squared, right? So this 4 multiplied by 4 is a 16 like this, and this will now in this form, this is omega, right? Omega here, and this is a here. So we can now write out the inverse Laplace transform. H of t is equal to 10, and 1 is the Laplace transform of del t, impulse function, del t minus 4 e raised power minus t, right? E raised power minus t, and sine omega is 4, sine 4t, and this is u of t here, right? This is to signify that u of t here, this is signify that this is for time t greater than or equal to 0. So h of t is given by 10 del t minus 40 e raised power minus t sine 4t u of t. So this is the impulse response of the given circuit.